Hello and welcome to the webcast titled The FACE Approach, Cost Reduction Through Portability and Interoperability. My name is John McHale, Group Editorial Director with Military Embedded Systems, the SOSA Special Edition, and the FACE Special Edition. I'm also moderator for today's event. To learn more about Military Embedded Systems, please visit militaryembedded.com and check out our articles, blogs, and podcasts on military technology. Our speakers today are Cliff Bilbray, Senior Solutions Engineer, Global Aerospace and Defense with the QT Group, Andre Odermatt, Principal Application Engineer with Real-Time Innovations, and Justin Pearson, Senior Director of Architecture and Business Growth for Wind River. This event is sponsored by the QT Group and hosted by Military Embedded Systems Online and Open Systems Media. Before we begin, I have some housekeeping items. This and all Open Systems Media webcasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. This webcast will consume about 40 to 45 minutes, leaving the remaining time for the question and answer session. Now let's take a tour of the viewing console. You'll find on your right-hand side an enter where you can enter questions in real time. We would like you to answer questions throughout the session while the question is still fresh in your mind, and then we'll address as many as we can during the closing Q&A portion. If you have a question for a specific speaker, please note so at the beginning of your question, or I'll offer it up to all three of our guests. If you have a question pertaining to the event operation itself, one of our technicians will get back to you during the webcast. And please note, as much as we'd like to, we may not get to all your questions today. In that case, someone may get back to you after the event with more information. Now, on the other side of your screen, there's a resources section. That's where you can find today's slides and speaker information. I've got two more features to tell you about. Your console is customizable insofar as you're able to manipulate all of these widgets, Q&A, resources, and presenters for your ideal viewing experience. You expand them to get a closer look or close them to have the presentation window automatically resize around them. For maximum screen size, close them all or use the full screen mode in the upper right-hand corner of the presentation window. To bring them back, simply click on the buttons in the bottom middle dock. In an effort to make our webcast more accessible, we have added closed captioning capabilities in more than a dozen languages. To enable this functionality, simply click on CC in the upper right-hand corner of the presentation window and select your language of choice from the drop-down menu. This webcast will be archived online at the same URL you used to join today's live session and be available within 48 hours. Once up, it'll be available for at least 1 year. Now I turn it over to Cliff to get us started. Cliff, take it away.
Thank you, John. I appreciate it. So what I'm going to do, I'll kick us off with a little bit of an intro into MOSA and FACE Conformance, the FACE technical standard, just for intro into what that is before we get into how each of us in our companies contribute to that environment, that landscape. So MOSA, Modular Open System Approach. So it's a technical and business strategy for designing affordable and adaptable systems. So this came out of US DoD, looking to reduce the costs of system integration for system integrators and then ultimately to the government, right? So many things it's trying to do, but cost control is a key point, right? So this is not just a suggestion. It's with the tri-service memo that went out. It's a requirement for all major defense acquisition programs. So this is a serious thing. It was established in January 2019, reaffirmed again in the winter of 2024, right? And it's required under US code. So this is a thing they big care about for the government, US DoD. They want to make this happen so that we can learn how to reduce costs for complex systems. The trick is MOSA's an approach, but not an actual specification. So it's not a list of requirements that tells you what you need to do that can be verified to prove that you are taking the MOSA approach, right? That is where the FACE standard comes in, the FACE technical standard. So there's also a FACE approach. So that also aligns with MOSA, where it's both a technical and a business practice, set of business practices, right? But it actually defines a technical standard, the FACE technical standard, which is a list of requirements. It is something that you can have independently verified by a third party to prove, to certify that you are actually conformant to the FACE technical standard and ultimately show that you have met the MOSA approach and the requirement from the US government, right? So that's how those two things tied together. And a key bit is this is for software, right? So MOSA is for systems. FACE looks at software specifically. And again, it's a technical standard that lists out requirements that here's how you establish that you actually meet MOSA. So there's a few key items that it's trying to do that it shares with MOSA. that I like to talk about. So you've got modularity. That's kind of key to MOSA. It's in the name itself. It's in the acronym, right? So what you have under FACE is you have what's called a unit of conformance, a UOC. That's the key unit that is taken through conformance. That is the basic module that's considered for the FACE technical standard, right? So that's where your modularity comes from, right? So you build up systems integrators are pulling in multiple modules, these UOCs, and are trying to integrate them together in the larger FACE environment, okay? And you have two things that are interrelated, but I kind of split them out in the way I think about them. So you have interoperability and you have portability, that these are key careabouts for MOSA and for the FACE technical standard, right? So when I think about interoperability, I think about the TSS, the transport services segment, which enables, so it's a little trickier to say than just enables communications. It's easier to think about, and this comes from Justin, so he may talk about this a bit later, but it enables anonymized application interfaces, right? So it's not just communications between components, but it's really how do you access data in an anonymized general way, where what you're doing is you're describing it from a conceptual, logical platform level so that that data can be accessed or the communications can be enabled without knowing without breaking down and doing like TCP IP and like knowing like directly how to manipulate the memory there and what everything means. It describes those things in a way that they can be worked with, right? So that's interoperability, being able to allow the UOCs to talk to one another and to be able to access outside resources by describing what the data is. So that's how I think about interoperability. And then you have portability. So portability is really, I think of it as getting at the system services that are enabled by the OSS, which is the operating system. And that's portability in the sense of moving from platform to platform. We can take a UOC on one platform and move it over to another platform and expect it to work, right, with the system services that are available there. So a couple things that the FACE technical standard supports. So you've got operational environments that are either POSIX based or ARINC 653 based. And then you have support for things like graphics through OpenGL, EGL, Vulkan, or ARINC 661 are typically used, right? So using these open technical standards, these open interfaces, right? So that's what the FACE technical standard spells out, and that's what it's trying to do. So this gives an example of what this looks like when it all comes together. So you can see a few things here. You see the segments, the PCS and the PSSS, which are segments where these portable UOCs live, right? And that's where and I'll talk about this a little bit more, and it's just a second here, but that's where Qt lives. So we enable application development in a UOC, right? So we are in the PSSS. I'll talk a little bit more about the PCS in a second, but that's where we live. And supported by the IO services segment, which enables platform-specific IO, right? So we allow keyboard, mouse, touch, those kind of things by making use of that. So the other folks that I'll allow talk in just a little bit. So we'll have Andre talk a little bit about RTI's product. So connects TSS. So that provides capability in the TSS segment, right? The transport segment. And then Wind River. So we'll have Justin talk about that in a moment and talk about, they've actually got 2 OSs certified. You have Wind River Linux, I believe, if I got that right, in general purpose profile. And then they also have VxWorks and the safety profiles. So I'll first talk about Qt a little bit, and then I'll hand the baton over and let Andre and Justin talk a little bit about how their products fit in. So just a little bit about the Qt group initially. So we come from the early 90s, a company called Trolltech. So we are a open source, dual commercial open source setup, where we've got a commercial entity set up, Trolltech, that has ultimately went through a few iterations. We were part of Nokia at one point, and we're now the Qt group. So we shepherd the project, the open source project, the Qt framework, if you're familiar with that. And we have a commercial version of that that offers some other capabilities, right? So that framework, so it's really known for HMI and UI development, and it's known for being very cross-platform capable. So desktop, mobile, embedded, not just OSs, but also many different hardware architectures, right? And we started looking into FACE because what's interesting here, our approach ends up treating FACE kind of like a platform, really. It's just another platform for us from a portability perspective, right? So that's when we first started looking at it. We're looking at how we could provide something that can fit in this environment, seemed like a good alignment. We went through the process of taking the framework and bringing it in. So what we have is a product that we call Qt for MOSA. It is adapts the Qt framework to the FACE approach and the technical standard. And the idea is essentially things that you can do in the Qt framework in normal desktop or normal Qt framework environment. Lets you do normal widget or Qt Quick QML applications on top of it, right? And then all the sort of things like event-driven programming with signals and slots that if you're familiar with the framework, you might expect, that's all there, right? So we provide that. And the other things we're trying to do is provide a starting point for FACE Conformant software for UOCs. So, and by providing a reference application, providing the conformance package that we use to bring it through. And also we'd like to be able to enable reuse for existing applications, right? So we treat it a little bit as it's just another platform. So if you've got something running as an application, a Qt application, the idea is that you could port it directly to the FACE environment using Qt for MOSA. And we brought it through conformance. That's our conformance certificate. We just made this happen back in August, just before MOSA Summit. So a little bit to tell you about it. Okay, kind of told you the parts of the product. I think one key bit is that what we do is we certified a UOC that includes the framework, but it also includes a reference application as one UOC. So those were certified together, right? So we took that through the conformance process. We made that happen. That's one part of the product. Now, if you were to use this as a customer, what you would do is you would take the reference application out, you put your own business logic in there, and you would combine it with that. Now, that also has to go through the conformance process, so which we enable by having a conformance package that we used that should make everything pretty easy to take through. The framework already went through once. It should move through fairly easily. And we also have all the evidence that we package with that. So that's what we do there, right? And just a few details on it. We are a general purpose profile. We aren't at the safety profiles yet. So that is one thing to be aware of. And then we are considered a platform-specific graphics service in the PSSS. And what we do is we take advantage of OpenGL and EGL. And the only last thing I'd like to mention here is that although we didn't certify in the PCS, that seems doable. We don't actually, so we're in the PSSS because we're making use of IO services for mouse, keyboard, touch, and those things. We do see a path towards potentially doing that in the PCS by defining a data model that you could do that through the TSS. So that's worth mentioning there. And with that, after a little bit of overview there, I'd like to pass this off to Andre to talk about how RTI fits into it.
Thank you, Cliff. So before I go into a little more detail on the transport services segment, let me give you a quick overview on RTI, who we are. We are an infrastructure software company. We specialize in creating software frameworks for intelligent distributed systems and physical AI systems. We have a product family, RTI Connects, and I will talk about this more in a little bit, which is based on the Data Distribution Services, or DDS standard. It's a data-centric communication backbone that allows distributed applications to securely share information at real time, making them basically working together as one. So we in a nutshell provide connectivity solutions that allow complex real-time and safety-critical systems to function autonomously reliable as one. So we make sure that the right data get to the right place at the right time. So having said this, here is a list of our main products. So we have Connect Professional. That's kind of the main product we have for mission critical distributed systems. We have Connect Drive, which is specifically for software defined vehicles. And we have Connect Micro for smaller resource constrained systems. We have a product called Connect Cert that is for safety critical systems. And then the one product we talk about today, which is Connect TSS, that is for FACE Conformant systems. It's basically an implementation of the Transport Services Segment APIs and mapping them to the DDS APIs. Now, I talked a lot about DDS, so let me talk a little bit what DDS, or the Data Distribution Services Standard, is. It's really a truly open standard because it's available for free, managed by the Object Management Group, OMG. It defines the APIs on the upper layer. It defines the APIs on the lower layer, basically the network protocol. It defines language bindings for different languages, standards that are in the standard. And we as RTI, we have additional bindings to things like LabVIEW, MATLAB, etc. And since we are in real-time systems, we are not only running on Windows and Linux, we have a lot of embedded operating systems like VxWorks that we support. Now, if you haven't heard of DDS, you might have used DDS because it's actually used in a lot of other different standards. If you're looking at like ROS, the Robot Operating Systems, that uses DDS as the communication frameworks underneath. The same for UMA, the Maritime Robotics Standard, GVA, the military vehicle in Europe. They're all using actually DDS as their protocol, underlying protocol. So even if you might not have worked directly with DDS, you might actually indirectly used it by using one of those standards. And that's kind of also one of the strengths, I would say, of DDS. Since it's used in so many different standards, we can make different standards, different applications following different standards to work together. But what we're talking about today is RTI Connect TSS. So that's how we support the FACE technical standard. As I said, it's an implementation of the TSS APIs, and then we map it to the DDS API. So you actually can make use of all the features and functionality that DDS provides. And you see in the stack down there that I have, we have the FACE application, the FACE UOP, then the TSS APIs that we then map to our Connect product. And depending on the profile you support, you can either use Connect Professional for general purpose. You can use Connect Micro for more smaller systems or safety-based system, or you can even use Connect Cert if you need to build safety certifiable applications. So we really have all the possible scenarios covered. We went through FACE Conformance for 2.1 and 3.1 with different products. So we have a few FACE Conformance certificates for our product, and also the TSS, and it's also created in a way that it can be certified for DO 178C Del A if safety certification is required. I said the same with our Connect Cert that would be used and connects with the TSS APIs that we have. We provide C and C++ API support, and we support all the required capabilities as far as technical standards. And in addition, we also support the transport protocol module. So we allow different transport protocol modules to be plugged into our TSS so we can interoperate with other TSS implementation that might not be built on the DDS standard. So we're really trying to support every single combination that you might need with your UOC to communicate across your system. And with this, I'm actually handing it over to Justin to talk about the Wind River products.
Thanks, Andre. Thanks everybody for being with us today. Hopefully you're getting a partial sense here of how you build a software stack, right? That ultimately helps you drive that cost reduction conversation using methodologies that support portability and interoperability. So you kind of got the user space perspective to that, and now you have the sort of transport anonymity perspective to that. So what I'm going to try to give you is a little bit of history on Wind River's play here, and then what we provide at the lower level of the stack with respect to what we call the operating system segment in the FACE technical standard, as well as what we do in terms of board support packages, right, where there's not as much guidance in the technical standard itself, what we do with virtualization, right? We live in a highly virtualized, cloudifying world, and there's only so much the technical standard can address, so it leaves some gray area that we really have to collaborate with from an industry partner standpoint on to make sure we head that right direction and we provide the most viable high TRL solutions to customers. So a really quick background on Wind River. If you haven't heard of us, we're across many, many different verticals, across billions of devices. For the topic of today's webinar, we're really focused on aerospace, defense, and government, which is the vertical that I support at Wind River on matters of our architecture, design trades, and business growth, right? We've been a leading real-time operating system with VxWorks for many, many years now. And we were the first RTOS to be certified conformant for the operating system segment with the FACE technical standard. And that's something we carry forward from participation in Airworthiness Technical Working Group, the business working group, and as well as that technical standard evolves, it's relatively automated with our own internal product processes now so that we can attest to that conformance, and then we can work that process concurrent to major releases of the product to provide that to customers as we go. With respect to product portfolio, like I said, Wind River is a big company in a lot of verticals, but we're selfishly looking at aerospace, defense, and government, which really draws us to 3 products traditionally, with opportunities elsewhere where we can really mechanize at the edge for a broader geodisparate environment, which from an operational perspective, that's really where we're going, right? So how do we do that more cost effectively and be interoperable as we go, right? We don't want closed ecosystems. So VxWorks was talked about a great deal. That's where your ARINC 653 real-time processes come into play. Wind River Linux, that was the first Yocto-based Linux operating system that is certified conformant. So that's a pretty big deal. A lot of times what we see now in terms of affordability is a lot of unmanned platforms, right? Unmanned platforms have very limited needs for your DALE safety certifiable case. It's not completely non-existent, but it is something that's less so than the manned side. So what we see is a little bit of balance, right? We're also the first RTOS here who can support OCI compliant containerization. So we can actually support a containerized deployed VxWorks alongside FACE certified conformant Wind River Linux. So we have a best of both worlds. So we're really trying to respond to that. And then when you add all the user space and the transport features that come with it, it's really a powerful solution for your customers. The other thing that's unique about Wind River is with respect to the Helix virtualization platform. So when you look at FACE, right, that's just one piece of the pie in terms of doing things affordably. But places which are still a bit squishy from an industry and government standpoint are, well, how do I make my virtualization approach interoperable, right? Is VirtIO, is application binary interface, are these the types of things that we need to adopt to go forward? So we have what you really need to review in terms of cost effectiveness is a change containment boundary mindset, right? So you have operational use cases, you have acquisition use cases. When you work with your customers, you really have to derive and decompose down from both those lenses to make sure that first and foremost, the warfighter outcomes can be achieved. And then from the acquisition standpoint, the contracts, the suppliers, the partnerships, they're all in place to support exploit and the positive manner of an open system, right? Otherwise, we're just doing things with one prime, one giant contract, closed ecosystem. And if you're not in the supply chain, it doesn't matter how open you are, right? So that's really our perspective. We're enabling, and that'll be the focus of today's topic here. From a functional safety standard perspective, right, a lot of this for us has been table stakes, right? As you can hear from RTI and QT, this is not something that's like the end all be all, but really it's just the ticket of entry, right? You want to start having conversations about how you can effectively apply commercial FACE certified conformance solutions for aerospace, defense, government use cases. we got to make sure we meet the bare minimum, right? Similar to security, there's many elements to the onion. It's the exact same thing when we look at open systems, right? So you have to look at it all in totality of what we're trying to bring in terms of the end item solution. So I can't just be FACE without thinking about how I'm making my certification evidence more modular for the integrated system. If you're looking at cost effectiveness, cost affordability, the most expensive piece to doing anything related in an airborne system is the safety certification tail, right? Technology is about 20–40% of it, right? Getting that right, making design decisions that help you in the long run. But really 60% of that cost gets ate up by all the stringent processes that we have to enforce, right? And those are getting better in terms of AI supplemented tooling and features with the more complex things like the real-time operating system, right? I want my grandma to be able to prompt her way through a configuration build, right? I don't want to just have at it in a legacy tool here, right, or in command line. So that's really important. So one thing that's really great about FACE, just for situational awareness, there is we've done a great job adopting industry standards that were pre-existing. So ARIC 653 isn't new in the FACE technical standard, but it was definitely acknowledged as that way. Hey, deterministic, spatial, time partition, environment that I can go ahead and adopt. I don't have to reinvent the wheel. We've put it in context, right, of your FACE reference architecture that was shown in the QT briefing at the very beginning of the call. The other thing that I'll caution you or motivate you to go look at is Advisory Circular 20-148. If you're talking airborne, manned or unmanned, reusable software component is a very powerful set of guidance that can sort of inform how you seek your reusable credit long term. So you're not just taking credit for the technology being open, you're taking credit from the certifiability aspect to it. So you're not opening up that really expensive Pandora's box in terms of cert. Security, really quick, right? You can't have openness without security. A lot of the security engineers that are passionate about this topic remind us that of every day. As things get more open, we really have to be diligent in terms of how we approach security of that product. So this will be more of a leave behind for the sake of today's topic, but it can be just as effective when you use things like a transport service segment in terms of security impact analysis, in terms of safety impact analysis, anonymizing those APIs, knowing exactly where these applications IO are leading across the system, not having a spiderweb monolith of point-to-point APIs. It not only helps us from a change impact analysis for safety, so that we can roll partial elements of the system without retesting the whole thing, but security as well. It's significant. To kind of bring all this together, right? The last couple of slides here before we can get to the fun, part of this, just questions, and you're really just back and forth with the attendees here. Is let's look at the nirvana state that we're seeking to get to, right? We know things are getting highly virtualized. We know things are getting highly cloudified. And we know what we've done in terms of the FACE investment over the past 15 years, right? Even when you have things like SOSA. So bringing this all together in context, your end state that we're really trying to get to is at our foundational layer. We have the change containment boundaries that allow us on complex multi-core systems, which on their own are typically very expensive to certify. But what we've done is we've added a modular element to that using the investment of FACE to give us clear-cut, safe, secure, interoperable virtual boundaries, as well as the software boundaries that live within those virtual machines or guests or time and space partitions in 653 that allow the user space to flourish in terms of one-to-many third parties, right? This isn't a go use QT, go use RTI, go use Wind River scenario. The fact of the matter is this is a commercial implementation of it that now enables one-to-many vendors to contribute to that ecosystem, right? So you have the commercial investment, you have the cert investment. Now it's more of a, how effective are you in terms of delivering capability to your customers? So if we look at this, there could be 3 or 4 nodes on the aircraft itself. If each one of those nodes have been built in the manner to where I can pinpoint the exact partition or the exact real-time process or the exact Linux container that I need to go deploy capability, all of these over-the-air advancements in the field today, all of these mesh networks, all these geo-dispersed capabilities that enable heightened telemetry and heightened command control, at a battalion level or where have you, right? They can finally be fully exploited in terms of operational effectiveness, right? So it really, really is important how we build the system from the ground up. And today is trying to exemplify if we can do that from an industry partnership standpoint, perspective, and we can come to consensus and still carry forward these 15+ year investments on things like FACE. In context, when you're talking what the use case outcome is, it's a no-brainer, right? And that's how you also can inform where you want to invest in terms of FACE and security and all these other things, right? Because naturally, you're going to spend more money on mission compute FACE investment, right, than you probably would on flight controls, right, which might be a point solution for the aircraft or the platform, right? Last slide here before I hand it over to John. Just want to exemplify some of the Wind River leadership. And of course, this isn't done without partners, right? But some of the high points here is from everybody on the call today, it's very rare that you're going to run into anybody with an end-to-end acquisition lifecycle experience with FACE, right? Before I got to Wind River, I worked the first open system architecture that ever got fielded for Army Aviation, right? And that was back when it was FACE Technical Standard 2.1.1. Right. So I've really got to live what it's like to chase your tail with that standard, right? As these acquisition life cycles will never line up to the technical standards evolution, sort of on purpose. But because of that, we have to make sure from a partnership standpoint and a customer standpoint that we're all sort of mutually vested in the programs that are taking advantage of not just the technical standard alignment, but the commercial investments, right, that are often dual use, right, to make sure that our operational outcomes, our acquisition outcomes can be achieved, right? So this is more of a leave behind, but I'll just say one last note on this one is when it comes to certification evidence, when it comes to FACE, the best way to balance that is by taking a integrated modular avionics approach. Commercial industry has been doing that for many, many years, right? As well as taking as much credit for your certification evidence at the beginning in your planning stages, so there's no surprises 3 years down the road when you certify the thing, right? And that takes shape in terms of the AC 20-148. So take as much credit as you can and be as open as you can as you go. So that'll be my last slide, and then I'll hand it over to John now. We can get into questions.
Thank you, Justin, and thank you, gentlemen. And Justin, that little tidbit you had in your last slide, I didn't realize you've been working with FACE. Your career has been tied with FACE for a number of years, from when you were working back with the Army. So the standard's been around for a while was the point I was making with that. And so I'm going to go right to our questions. And I got one for Cliff. And this one I found interesting, Cliff, because at the beginning, I'm glad you said that MOSA is an approach. It's not a standard, because I get that a lot. And this question says, what would be required to certify QT for MOSA in the PCS segment? How do you answer that, considering you really don't certify toward MOSA, but toward maybe one of the examples?
So yeah, certifying towards FACE. So yeah, that's absolutely true. So MOSA doesn't specify a way to certify towards it directly, right? So you use one of the supporting standards or the standards it feeds up to prove that, right? Whether that's FACE or SOSA or some of the other ones that are out there as well. So again, we are certified for Q. What we did was certified a UOC within the PSSS. And the reason we did that was because we wanted to take advantage of the IO services segment in order to be able to use keyboard, mouse, touch input that you would expect for most Q applications, right? And there's not a platform independent way to do that right now, right? So that's what drove that decision. So that was the easy way to do that. There's just a little bit of code that lives in the PSSS, in the IO services segment that basically passes data over the IO interface in order to be able to feed our event handlers to make that work. So that said, so we're directly using those drivers essentially, right? So there's nothing in the requirements for PSSS that's different or that we couldn't meet also in the PCS outside of the fact that we're making use of the IO services. So there are a couple ways to do this, and Andre could actually probably feed more into this. So we could live up to the PCS. So there's kind of two ways you could do that. You could model. So you need a data model for these events, these mouse, keyboard, touch events that would come through the TSS, right? And then you could feed that one of two ways. You could have a little small PSSS UOC that passes things along from the IOSS. But you also have, and this is where I get a little fuzzy on the TSS, there's a possibility of using a TPM module, I think, as well. There's another way that you could bring in data. So there's a couple ways it could be done. We didn't do that for our initial certification. We're very new to the FACE standard, so this is our first foray into the whole thing. So this is how we did it for our initial take, but we're continuing to look at how we can support things like getting things into the PCS and stuff like that. So does that answer your question?
Wasn't my question, it was from the audience, but I hope.
Oh, I guess. Or yes.
You wanted Andre to chime in on that? You mentioned that earlier. Andre, do you have anything to add?
Yeah, I can chime in a little bit. So yeah, there's the whole conformance process that actually the FACE consortium supports, and as Cliff said, and you need, if you write a PSSS or PCS, you need a data model with it, and then there is a conformance test suite that actually checks your data model and some of the FACE requirements. And if you want to really go through with the full conformance, you would need to engage with the VA that actually then does some of the additional inspections as well. But adding to another thing that actually Cliff mentioned, which I think is very interesting, is how to bring data in. So there is the TSS, which is designed to have the communication between PSSS and PCS, and within there is that transport module capability, which is initially was designed as a way for different TSS domains to talk to each other. Basically, TSSs that are based on different protocols. So you have a DDS TSS, and you have your own, let's say, 0MQ or whatever protocol TSS to talk together. But recently, there's actually that TPM approach has also been used to bring in data from other connectivity, like maybe a CAN bus or something like this, even though I think the initial idea with the FACE technical standard was to do this through the IOSS, but certain things can also actually be done through the TPM. So it's kind of a very interesting approach there.
Okay. Next question I have is for Justin. How do you balance investment of FACE without putting yourself in a do loop of updating to the latest standard version just for the sake of it? Is that kind of like what we do on our laptops?
yeah, mandatory updates. So that's a good question. This one has been brought up for, I guess, a couple webinars now with respect to MOSA virtual summits, and basically anytime we're talking about open systems, right? And the way this has worked on some of the Future Vertical Lift acquisitions, and it was sort of a lessons learned that we adopted from like UH-60 Victor and many other platforms, is that you have to, when you're using these government frameworks, it's not necessarily about all the libraries that say, well, you're going to follow this functional taxonomy, you're going to define your MBSC architecture in this logical way, right? What it starts with is working with the end user and the community that's developing the capability doctrine to identify what the actual use case is from an operational outcome, right? So you sort of pseudo define the boundaries from an end capability that have been hindering the users in terms of operational effectiveness for decades upon decades, right? So you have to start with an operational use case and then the acquisition use case that has to accompany it. The problem we've had on other acquisitions is that we've had highly modular architectures, but we've spent 5 to 10 years essentially investing in one set of a vendor ecosystem, right? And when you're talking FACE in the airborne community, which is the Future Airborne Capability Environment, and yes, you can use it for other things, and it is being used for other things. What you have to acknowledge is the sunk cost with certification. So if you spend 5 to 8 years investing in a FACE implementation, but you only have one vendor that can certifiably touch that system, it doesn't matter how open you are. So exemplifying that fact in a type of use case decomposition, modeled or not, it has to be informing where FACE is applied to your architecture. So you don't end up giving a vendor, go do FACE everywhere for the sake of it, right? FACE exists to achieve operational outcomes and to enable us to rapidly deploy capability and update it once it's out in the field.
I've got a question here for Andre. I think that kind of jumps onto that one. Are the different editions of the FACE technical standard compatible with each other, Andre?
That is a very good question, and it really depends a little bit on what kind of compatibility are things you're looking at. There's definitely, I would say, between the 2 series and the 3 series, there have been a lot of changes. So there's really not a lot of compatibility if you're building a UOC, since the APIs and certain things have changed. However, if you look at below it, if you use like the RTI Connects TSS, since we are on the wire, we're using DDS, a standard wire protocol. If you're building a USC or 2.1 which results in the same IDL or data type being sent, you can communicate with the application that you build according to FACE Technical Standard 3.x, and they will communicate on the wire by itself, even though the UOC itself, you couldn't move easily from 2.1 to 3.x since the API has changed. But you can make it work actually on the wire itself to have different versions of the technical standards to talk to each other.
Question.
I don't know, Justin, if you wanted to add something.
Yeah. I'm sorry. I was John. If it's okay, I can.
No, knock yourself out. Go ahead.
Yeah.
So that dilemma is tried and true for sure, and it's going to keep happening, right? As long as there's sort of a parallel effort, right? And we are getting better at it. The consortium does acknowledge that we have to improve upon who's vested in what, right? But in terms of where we're going from a technology standpoint, boards are coming out nowadays with much more capable virtualization technology, right? So it is affording us similar levels of determinism and safety and security that traditional single core systems have brought in. So all that means is that there's more hardware resources that can be anonymized and virtualized, so that I have a broader change containment boundary, right? Like a virtual machine to offer the first party that touches the system or the third party that touches the system. So I can have a completely separate guess that's only FACE 2. whatever, and I can have another one that is FACE 3.x, right? So in terms of the opportunities you get in acquisition, I think the technology is there. It's just have to make sure we architect it appropriately from a use case standpoint, right? Acknowledge the reality that standard will change and that transports will become incompatible.
Okay.
And I'd just briefly add that like the ability to use the newer editions is very important to us, because for us to have brought what we did in, we're actually relying on very new versions of the standard. So in order to be able to use the C++ versions that are newly available in 3.2, right? So just add that on to the end of there.
I've got a question here that's not assigned, but I'm going to throw it at Cliff. Do your solutions include a hardware component, or is your platform a containerized application that runs on a hardware offering? Came through just at the end of yours, beginning of Andre. So I'm guessing it's you.
Okay. There's kind of a simple and there's a more complex answer here. So I think from a UOC perspective, the whole idea is that it's all hardware independent, right? This is just going to go from system to system. It won't matter, right? It's just software that'll move around. It's a little more subtle than that, because the FACE technical standard doesn't get into like hardware architectures and things, right? So it specifies, here's how you write code, and here's the APIs that you're allowed to use in the interfaces, right? But it doesn't say anything about, okay, compiling for ARM versus Intel or any of that kind of stuff. So it just assumes that all works. So there is a hardware aspect to it that is not addressed by the FACE technical standard in any way, right? So that's a little bit of complication in it. I would say from living in the PSSS, living as a UOC, the theory is that it doesn't matter much. So from our perspective, hardware doesn't matter much, although there is that complication. Now, that said, Andre and particularly Justin probably have something to say about hardware for sure now, because I have no doubt it affects how the operating system works, but maybe I'll pass it off there to either of you.
Just to add to it, I mean, the FACE technical standard really focuses on portability, but not on binary portability. So it acknowledges that in order to port it from one hardware to another, that you may have to recompile and rebuild the software, but you shouldn't need to change code. You just need to recompile it. So that's kind of how the technical standards addresses the portability. Now, as far as us, RTI, we just have a software solution. We are independent of the hardware, and we work with different hardware vendors, and we can basically run and build our stuff on pretty much any hardware. And I'll pass it on to Justin.
No, it's a great point. I think what you have to be careful with that, once you reach below the operating system segment layer, one thing to leave here knowing is the FACE technical standard does not yet address virtualization and operability. So the SOSA consortium has begun to touch on this one. If there's not any authoritative must go do this type scenario, but things like non-safety critical, containerization type deployment, OCI compliance, VirtIO, OpenAMP, these types of things are industry, kind of cutting edge efforts for this. It's not that they won't ever be in there. It's just be careful once you get below that layer, because that can negatively affect your impact analysis, right? When you're looking at, changing boards, right? You just make sure whatever your FACE certified conformant is, you got a certifiable BSP underneath it.
Andre, are there hardware? This is just coming from me, but have hardware companies taken an active role within FACE to kind of work with you guys? I mean, I know companies like Abaco are. I don't know if Curtiss-Wright, Mercury, those others are in there on the membership consortium. Is that something that you guys are looking at, or the consortium's looking at?
There are, as you mentioned, there are hardware vendors that are part of the FACE consortium, and we've worked with some of the hardware vendors to build kind of complete stacks where we have an operating system, the TSS, and a specific hardware that's all certifiable, built together, and we can have as a reference implementation. Yeah.
Okay. Question for Cliff. As a software supplier, why might I consider FACE conformance in the absence of a requirement? Basically, I guess they're asking, is it worth the money to do in time?
Yeah. So, right. And that's a reasonable question, is because you look at it like this. For a software supplier, this is not going to save you money making something FACE conformant, right? The idea is it helps the system integrator, it helps the government control costs and to move things around. I think the way to think about it in the absence of a requirement is there's also a risk that may become a requirement in the future, right? So that's something to consider. And especially as FACE seems to be adopted more and more. So we've seen expansion, the consortium, they're looking to expand into NATO, right? And like looking at how that could happen, right? So as it gets more and more adopted, it may be good to align with it early and be ready for that to come, right? So that's one aspect of it, right? But it also, there is advantage as well from you're developing a system or developing a component for one system, maybe get ahead of being able to port that to the next system. So it makes you more competitive to bid and be part of another system in the future, because you have this in place, that it can be ported or that you can, you have greater likelihood or make porting and that process is going to be easier because you've adopted the standard early and to open standards, right? So.
I think Justin would like a shot at this too.
Yeah, I think if you're looking at it in terms of, there's two different perspectives there, right? There's the perspective of you're going after an opportunity, right? And you're looking to invest in how to mature your technology to make it more competitive, right? And increase P-win, right, for that. The other piece to it is you're already in active acquisition and you're trying to help yourself long-term, right? So you have to look at what the outcomes for that acquisition are and where you need to enforce the FACE technical standard to help you get there. But I can tell you, just in terms of some Defense Acquisition University metrics that we gathered about 5-6 years ago, it was about 5 to 10% of the actual software budget that went towards the API alignment. But I can tell you, it saved the program during a flight test, because we had 45 plus applications and 10 plus partitions, right? And we had 2 applications that needed an update mid-flight test. And what the FACE technical standard alignment allows us to do is to streamline that impact analysis. So what typically took 2 months took a week and a half. And that was 75% less than what the vendor had been traditionally working with, right? And that's at the time $35 million a build, right? So that's not something we want to roll. So we retested 2 partitions and continued on our way and didn't have to burn all the more flight hours, right, to get there. So I'd say even if you're not looking at a certified conformance end item, it's really good to do from a simplification of the impact analysis.
And to add to it, I mean, one of the MOSA principle is that you actually show conformance with the standard that you're using, and this is a easy way to achieve it.
Okay. I've got a question coming up, and I'm going to give this one to Justin, since he and I were just talking about this 2 days ago. Are you aware of FACE implementation in the area of flight simulators, maintenance simulators, or integration labs? Justin?
Yes, but as a byproduct of not investing in a duplicative manner for emulated flight software. So what has typically happened pre-FACE is that we get the build from a prime, right, and then we sort of emulate that in a lab environment. And sometimes we can load that operational flight program equivalent on the target, but other times it's not the same hardware. Right. So I can tell you a lot of the Black Hawk users in those training devices it's not a 1-for-1 representation of the MFD they're going to see in the actual Black Hawk, like a 60M. So what we've looked at trying to do is, well, what's the boundary that gets drawn so that I can have a cross compilation on targets, right? And that's a very simple thing to do. FACE doesn't cover all of it, but absolutely we're seeing it. But it's just the byproduct of being able to have the same compilation compiled for multiple targets, right? So that extends from FACE, but it starts with, if you're already doing it on your platform, it simplifies a cross-target compilation.
So if you're flying with it, you might as well train with it, in other words.
Exactly. Please don't pay somebody else $500,000 to emulate it in its own,
Well, along those lines,
kit.
Andre, I know RTI goes a lot to the IATSIC show, which is the military's big training and simulation show in the U.S. in Orlando every year after Thanksgiving. Do you see a lot? Does RTI see a lot of people talking about FACE there at all? Just out of curiosity, what do you hear? I don't know if you attend, your colleagues.
I mean, you definitely hear people talking about FACE there as well. And I mean, to add to Justin's point, is I see more and more that they're trying to bring actual systems into the simulation environment instead of just simulating it, that there is a mix of certain things simulated and then actually having real components that then be brought into that simulation environment. Yes, we definitely see that.
Okay, Cliff, where is MOSA and the FACE, where are MOSA and the FACE technical standard applicable outside of avionics?
Okay, so I can't remember who said it. It might have been Justin earlier. So we've seen there has been expansion outside of avionics. I've heard stuff, unmanned systems typically, right? So that kind of thing. So not just avionics. So avionics, I suppose, in a way with drones and those kind of things, but also, like ground systems, those kind of things. So I've also heard there's a lot of movement in ground vehicles as well that we've seen interest in FACE and MOSA. So those are the places where I've heard of it.
So like FACE from how you safety critical applications, there's similar standards to DO 178 that are available from automotive. Is it kind of along those lines? Is that?
So that's an interesting question that I don't actually know
the
full answer to, right? So you've got places where and this is where we're interested in bringing stuff in the general purpose profile, there's places where safety standards don't apply or not DO 178C. Now, automotive, you tend to, at least in the commercial world, there's things like ISO 26262 and things like that. So there's safety standards, but they're not, you don't want to do avionics DO 178C level certification for things. So I think that is still kind of in flux a little bit, what that looks like. I actually don't know what is being kind of standardized on there, but there's definitely been more interest in it in the ground vehicle side, for sure. I maybe Andre or Justin can talk to it, but I'm not sure what we've seen as far as safety standards there or how that would align with what we're doing in FACE.
Really quick on the safety piece, right? The DO 178C has a lot of sister standards, right? And they all kind of plagiarize from each other at different points in time. So one benefit the ground community has had as they've gotten into things like UAS deployment, counter UAS deployment. They are entering into that sort of safety critical realm where a portion of that system has to be certifiable to not have a detriment on manned platforms and things that can kill you in the air or on the ground if it falls from the air. So they're leveraging the pedigree, but not necessarily going as full blast with the certification investment. So a lot of the conversations have revolved around equivalency, right? And if you're familiar with automotive, it's all about ISO 26262. Also, the ground-based equivalent is sister accompanying standard for MOSA VAC. That's DO278, right? That's CNS systems and things like that. So there's overlap that I think that is always going to come with FACE, but not a lot of folks know where FACE lives in that technical standard, in the this certification like safety standards that RTCA publishes. So that's probably a good webinar topic in itself because we present that with a couple customers.
I feel like Andre and I might have had similar talk at that once on a webinar. But yeah, I've got a comment in here from the consortium outreach committee. Just sent a note and saying the FACE is also in commercial oil and gas in addition to ground vehicles. So to answer the audience's question.
Nice. I was waiting for them to say that we used the trademark wrong. So
no, that hasn't come up yet, but probably won't in a live event. So you can't really talk a trademark. But I'm probably going to get yelled at and say, yes, you can, John. But I have time for maybe two more questions here. I'm going to go with this one, and I'm going to give it to Justin because he did mention SOSA before. How does FACE relate to all the various government reference architecture frameworks and also, I would say, other technical standards like SOSA? I would add to that person's question.
Yeah, for sure. So a lot of these government architecture frameworks are typically more enforcing how they want the system architected from the top down, right? And a lot of what we referred to before as far as like, what's my functional taxonomy, right? So it's one thing to go do FACE, but like, how do I define what an air data computer functionality is, right? Without it being different between Navy, Air Force, Army, and space, right? So there's frameworks that help you in terms of the context of what you're implementing, right? So it's more than just an API alignment, right? Really, if you've aligned APIs, but you haven't functionally characterized the system in a consistent way, like from a data model standpoint, to speak the same language, the same love language, then it kind of, you hurt yourself in the long run, right? It's the same thing with logical architecture. So I would look at the frameworks in general as libraries of content, right? That will be leveraged to decompose the architecture of the system functionally, logically, and physically, right? And FACE comes along for the ride each step of the way, right? But I've seen reference architecture frameworks that basically just say, hey, the system architecture shall implement FACE technical standard 3. whatever, right? But really how that gets mechanized depends on the logical decomposition of the architecture and then physically where it gets enabled, right? You don't want to go do it for, you don't want to spend all your money on a health and usage monitoring system FACE application when you only got finite funds from an architecture standpoint to get it right on mission computing the first time. So I just look at it as library of resources, but it does walk the dog as you decompose the system functionally, logically, physically.
Okay, I got a question here for Andre, and I think this is a really good question. What does it take to get an application FACE conformant? And I would add, how long does it typically take?
I think Cliff is probably the best one to answer on how long, since they just got FACE conformance on their product. He probably has the most experience right now.
I think the first time you do it, longer than you think it will.
Yes.
I suspect the second time you do it can be pretty quick, actually. Once I think the tough thing I think is really, so I think CTS and working with that, actually working through the mechanics of putting things through that can be difficult. The first time through, it's going to be difficult. Mm-hmm. It also depends on what you're bringing through certification. So I think something that we did that's a little different is we brought through our framework as pre-existing code. So we had to take this through and adapt it. Now, I think and this is probably something for like, if somebody was to do this, if you're doing new code, I don't think it would be as bad. If as you're going along, because so much of conformance and showing that you meet the standard is through this tool that can just be run against your code. I would say that if you're doing new development, if you start early with CTS, you're continuously running your code against that. you know if you're doing something you shouldn't be doing. If you bake it in from the beginning, it's probably actually not that bad, right? There's going to be a learning curve understanding the technical standard, and like I can't get around that. I'd say it was a little painful for us, but it was a lot of that had to do with we took a very large legacy code base through, that was actually also doing some things that were pretty new to the standard as well. So we used modern versions of the C++ standard. We were using C++ 11 and could have used 14, right?
What
so
is
that
CTS?
actually gave us a little pump.
You mentioned CTS. What is CTS?
Mm-hmm.
You spelled
Oh,
that out?
I'm sorry, stepping back. So conformance test suite. So the standard has a whole lot of requirements. I don't know what percentage. I'd say maybe 90%. I don't know. Somebody else could take a stab at it, but a large number of those requirements can be verified automatically by running the code through a tool that is provided by the consortium, right? So this automates the proving of these requirements for that code. There's always some that you have to go provide manual evidence for and go provide justification. There's always going to be some of that, but a large part of it can actually be verified through this mechanical, this tool, right? Which is actually kind of a beautiful thing about the standard, right? It just like you just run it through, it's conformant or it's not, and the tool tells you that. So if you get on early with that can, if you're doing new development, then you'll just know when you've hit something that, oh, I can't do it like that. I need to do it a little different. Like, find out early. So.
Yeah. And I think also the key is if you're planning to go through FACE conformance is pick a VA and engage with the VA pretty early on as you go through the process. As they
VA stands for Verification Authority?
Verification Authority, yes, so that they can actually guide you through the process as well, and because they've done it before. And I definitely agree with Cliff. The first time it can be a little bit longer and more painful. Once you have done it once, you get into it and you kind of know what to expect.
And I've got a little note here from the director of the FACE Consortium, Alicia Taylor, and she would like to let the audience know the FACE CTS, which is what is it again, Cliff?
Conformance Test Suite.
Conformance Test Suite is publicly available and free for anyone to use. It is available from the FACE website at www.opengroup.org/FACE. And along those lines, Andre, is there also on that website a list of FACE conformant applications?
It's not on that website itself, but if you go there and click on conformance, there is a link to a website that has all the products that have gone through FACE conformance.
Excellent. Thank you, gentlemen. That brings us right to our time limit for today. Sorry we cannot get to all of your questions. Someone may get back to you after the webcast with more information. I'd like to thank Cliff, Andre, and Justin for speaking today, and QT Group for sponsoring this webcast. This was a really good one, guys. A lot of great questions. So thanks to our audience for the good questions. This and all Open Systems Media webcasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. This event will be archived online today at the same URL you used to join today's live session, as well as the URL showed on your screen, and will be available for at least 1 year. I look forward to seeing you on future Open Systems Media webcasts. Goodbye and have a great weekend.
Thank you.